Hi, this is Mrs. LaBarbera. This is Chapter 10, Basic Waves Review. So I just want to go over a few topics before you're going to take assessment, Chapter 10 assessment. So first of all waves are caused by a vibrational source. It has the same frequency as the source. So all waves, doesn't matter what type of wave it is, its frequency is the same as the source. And also all waves, doesn't matter what kind of wave it is, it transfers energy. So we know we have learned in this class, regions physics, there are the 4 different types we kind of focus on. First is how it's vibrate, longitudinal versus transverse. Longitudinal means the particle vibration is parallel to wave's motion. On the other hand, transverse, in a transverse wave, the particle on a wave moves in perpendicularly to the direction of a wave's motion. The other way to separate waves depends on how it carries its energy. Electromagnetic wave can travel through vacuum. It doesn't need any medium to travel. Like the sun's energy travel to Earth, that does not need anything to travel. There is no medium between the sun and Earth. On the other hand, many waves need a medium to travel. For example, ocean waves, you can't have ocean waves without water, right? A slinky wave, you can't have a slinky wave with a slinky. You can't have sound wave without a medium such as air. So, the 4 types of wave, longitudinal, transverse, and the electromagnetic versus mechanical. Light wave is transverse and the electromagnetic wave. So light wave we need to pay attention to. We're going to learn about light waves later. And sound wave is another very important wave that we are very familiar with. Sound wave is longitudinal and mechanical. Now, wave can be described by using the following words. How do we describe words? Wave, like, when we started kinematics, we describe motion, right? Using velocity, displacement, and so forth. To describe wave, we use words such as amplitude, period, frequency, wavelength, and speed, and there are many more, but you really need to understand what each word means, okay? How is period and frequency related? Period is inversely related to frequency. That means the longer the period, the longer the time it takes for one wave. Therefore, the less frequent the wave will be. So T equals 1 over F. F is in hertz in this case, T is in seconds. In this case, because T equals 1 over F, that gives you the period times frequency always equals to 1 for any wave, okay? Frequency or period, again, is determined by the source. It's not determined by anything else. Determined by the vibrational source. Amplitude is measured from the middle or equilibrium position to the highest point or to the lowest point. So amplitude indicates a wave's energy. For a sound wave, loudness represents its energy, so loudness represents its amplitude. For a light wave, brightness represents its amplitude. Now, on the other hand, for slinky, it's just how strong you push the slinky or move the slinky away from its equilibrium position. Speed of a wave. Speed is just how fast it travels. Speed, from what we've learned in kinematics, is distance over time. It's a ratio, distance over time. Since for one wave, the distance of one cycle is the wavelength, and the time of one cycle is a period. So velocity of the wave is the wavelength divided by period. Since 1 over period is frequency, So the wave equation often we see is lambda times f, the wavelength times frequency. So we have learned many equations kind of similar like this, even though it is determined by, if we know the frequency and the wavelength, we can determine the speed. However, the speed does not depend on frequency or wavelength. What does that mean? How could that be? This is how could it be. When you change the wavelength, you are not changing the speed, you're changing its frequency. Similarly, if you increase or decrease its frequency, the speed is not affected. What is affected is wavelength. Okay, so we've learned equations like this, such as Ohm's law. Ohm's law says the resistance equals to the voltage over current. So it's a ratio. When you increase the voltage, resistance doesn't increase or decrease, but current would increase. So that ratio stays the same. It's the same thing here. The other relationship we have learned probably is gravitational acceleration. That's the gravity over mass. So when the mass increases, gravitational acceleration does not decrease. Gravitational acceleration remains the same. So when the mass increases, what happens is gravity also increases. So the ratio stays the same. So basically this has the same idea. Okay, the ratio stays the same. Velocity stays the same for the same medium. Okay, let's do a couple of examples. This diagram represents a transverse wave. So which 2 points identify the amplitude of the wave? So from the last slide, we know amplitude is from the middle equilibrium to the highest, or from equilibrium to the lowest point. So out of these choices, the answer is D. Next one, the amplitude of sound wave is clearly related to which part of the sound. So amplitude represents energy of the sound. So which one represents energy? The loudness. The louder you speak, the more tired you're going to be. So because loudness indicates energy. Amplitude represents a wave's energy. Energy of a water wave is closely related to what characteristics? Okay, we just did that. Amplitude represents energy, so the water wave's energy is represented by its amplitude. So it's like high waves or low waves. So when the water wave is really high, you should stay away from it because it has lots of energy. Next one, if the frequency was doubled, what happens to the period? So how is frequency and the period related? They are inversely related. So if frequency is doubled, denominator is bigger, t will be halved. Take a look at another question. This is a graph. It tells you the information of the amplitude. In this case, amplitude is 0.01. Another information it gives you is the period. Period is 0.05. What is the frequency? So we need to remember how frequency and period relate. They are inversely related. Frequency is 1 over period. So it's 1 over 0.05 seconds. You get 20 hertz. Another example. So a 5.09 times 10 to the 14 hertz electromagnetic wave is traveling through a transparent medium. The main factor that determines the speed of this wave is there is only one thing determining the speed of the wave, which is its medium. So the nature of the medium. Okay. Another one. A distance of 4.0 times 10 to the negative 2 meters separate successive crests of a periodic wave produced in a shallow tank of water. So what this distance really tells you the wavelength. Its crest passes a point in the tank every 0.1 seconds. This 0.1 seconds tells you the period. What is the speed? So speed equals distance over time. This distance in this case is the wavelength. The time is the period. So you have 0.4 meters per second. 0.4 meters per second is the same as 4.0 times 10 to the negative 1 meters per second. Another example, an electromagnetic wave traveling through a vacuum has this wavelength, 4.5 times 10 to the negative 1 meter. What is the period of this electromagnetic wave? So let's see. Electromagnetic wave, we probably have not mentioned this yet, but all electromagnetic waves have the same speed, travels with the same speed in vacuum or in air. You can find that information on a reference table. So it doesn't really matter what its wavelength is. We know all the speed, we also know the wavelength. How can we find the period? You use that equation. Time is d over v, so period is the wavelength divided by speed, which gives you 1.5 times 10 to the negative 9 seconds. So the answer is B. Last example, this diagram represents 4 waves, A, B, C, D. A, B, C, and D, they are traveling in the same medium. So it doesn't matter what the wave, they are all transverse waves, looks like the medium is the same. So that means they must have the same speed. The question asks you to rank the period from the longest to shortest. So let's see, all the 4 waves must have the same speed. Let's see the speed and the period, how are they related? Speed equals to wavelength over period. So what's different from these waves is their wavelength. So remember, the wavelength does not change speed. The wavelength in this case changes the period. The longer the wavelength, the longer the period. So the ratio stays the same. Which one has the longest wavelength? B has the longest wavelength. A and C have the same wavelength. Look, they pass the same point. And D has the smallest wavelength. So the rank would be B is greater than A, which equals to C, then is greater than D. And that's how it's ranked. Thanks for watching. See you next time.